Thank you. So I don't need to do anything already. I got my uploads. Thank you for coming. Come again soon. Hello, my name is Yakov Fain. I work for a company called Ferrata Systems. It's a consultancy that started back in 2006. We started as Java Flex shop consulting. We developed tons of stuff in Flex framework. Anybody use Flex in the audience? No. Wow, different camp. Anyway, 5 years ago we decided that we need to move out from Flex, not because we didn't like it. We like it so much even today. But Flash Player is a VM. VM for Flex is not popular anymore, if you know. So we started to look for a new framework 4 years ago. We didn't like anything in JavaScript at all. Until now, we see Angular 2 and TypeScript. This is what we like, and we started migration slowly because the code base is huge. So I am a co-author of this popular book, popular because Amazon sells it really well, and because of that, they don't give any discount. But down there, if you want to buy it at manning.com, you'll get 40% off or something like this with this promo code. That's it about me. The agenda. As Ben said, it's not, his presentation was not about React. My presentation is a little about Angular, but mainly I want to talk about a certain portion of programming in Angular, and not only in Angular, specifically reactive programming. And that's why this presentation will be split in two parts. In the first part, I talk about basic about reactive programming using RxJS library. Then I'll show you how these techniques are embedded, incorporated inside Angular 2 framework. Anybody used Angular 2 in the room already? Not too many people. Big mistake. We are not in the Bay Area. So it's super popular here. It's a platform. In Bay Area, they are very smart people. A guy can pick up a library that knows only how to render data. And then he will go and pick up library for routing, library for this, for that, for layout. We can't do this. We need a platform, right? Because people will come and go, and we want to have a platform in the store. So people can read other people's code, right? We need to have strong typing. That's why we use TypeScript, right? Because we don't want to find about errors when the program already runs. Anyway, so let's start with RxJS, specifically version 5, which was rewritten in which language? In TypeScript, of course. So RxJS 5, all these repositories are there, is included with Angular 2. So it's already there. And it's used in many cases. But I will start with simply RxJS without any Angular for now. You can use it either by including this file into your index.html if you want, or you can install it using npm in your project. Documentation is there. RxJS 5 is known for bad documentation. Actually, all Rx libraries are known for poor documentation. Poor meaning they didn't spend enough time to make it simple. Maybe because of that, it's not that popular, even though it's great. So, but hopefully after this presentation, you will be able to read at least documentation and learn on your own. Let's talk about main players in the reactive, in RxJS library. But actually, before talking about that, I'll tell you a couple of words. There is a whole movement, so to speak, on doing reactive programming, meaning it's not me who keeps calling you, are you ready, are you ready, do you have something for me? But it's I'm sitting and waiting, and you are pushing me data when ready. Sometimes people use the term observer pattern. It's more than this, the pattern, and I'll tell you why. This is a super popular library. It was created in Microsoft, Rx.net, many years ago. And then it was so popular, so it was converted into other languages. And it exists in Java, in .NET, in Python, in PHP, you name it. and of course in JavaScript. And it's a library that you can add to your existing project. You don't have to change the style of programming. No, it's a library. Add it and use it here, there, and there, wherever you want. But now let's talk about the main terms, the main players, so to speak. These are the main players. Observable. It's something that pushes the data at you. It's a stream of event or stream of data or stream of values, you name it. And what is a stream of data? Everything is a stream of data. Like data about stock market coming in, it's a stream of data. The user is moving a mouse on the screen. Each coordinate is actually coordinates of the mouse movement is a stream of data. So in many cases you have a stream. The user keeps typing in the input field on the screen. You got stream of characters pushed at you, and you can subscribe to them and read them and process them. So just remember, observable is something that pushes data. Will it push? I don't know. But if it will, something has to be ready. What is this something? Observer. Observer is somebody who cares about the data, receiving the data, and who knows what to do with the data if or when it comes. Remember? Observer. Subscriber is a class or a function, if we are in JavaScript conference. It's a function that brings together observer and observable. Observable says, I can stream you stock prices. That's fine. Until somebody subscribes to it, no streaming happening. But if you use subscriber, then you will say, I want to subscribe to that stream, and here's my observer. And the superpower of Rx libraries is in operators. As the data moves, you can put a bunch of functions, you can change them one after the other. And as the data moves, it gets transformed. When it arrives to the subscriber, it may be transformed 10 times. It's very composable and nice. Now let me explain you how this works using simple example. Imagine that you have a data source somewhere, like a printing press that prints magazines, right? And there is a mailman, right, who delivers the magazine, right? So mailman is like an observable, the stream of magazines in this case, right? Now we have an observer and subscriber. You know these people, right? So Brad Pitt has a lot of money. He can afford to subscribe to a woman's magazine, right? But he doesn't need it. He doesn't know what to do with it, right? But on the other hand, Angelina Jolie has no money to subscribe, right? But she knows what to do with the women's magazine. So what happens is Brad Pitt is subscriber, but Angelina is an observer. So whatever entity knows what to do with the data is an observer. Subscribers just brings together observable and observer. And what's cool about this API is that there are only 3 functions to call: next, error, and complete. So if observable brings a magazine, it technically calls the function next on the subscriber, saying, here's the next element. It could be a magazine, it could be a stock quote, it could be bidding on the eBay or other auction, right? So it could be gaming, online game, many players, somebody's making a move. If there is an error, something happened. Again, observable will use a separate dedicated channel and invoke the function error on the observer. If the stream is over, it's going to invoke the function complete. So basically, these are the 3 main things that observable allows: emit the next value, notify the observer if there are any errors, and inform the observer the stream is over. An observer, remember, it's Angelina Jolie, knows what to do with the data. Accordingly, if you will write an observer class or functions, it needs to know three things: what to do if the data arrives, what to do if the error arrives, and what to do if the end of stream happens. So how do you create an observable? Again, I'm now talking only about RxJS, no Angular 2 in the picture yet. There is a class Observable, and it has a whole bunch of different methods that allow you to create observables, so something will start happening, something will start sending data. Create, observable from. Say, for example, you can take an array and say, I want to take the data that you have and send them over, push them to the client, push them over time. If the data is in the array and you're just looping through the array, it's not an observable. You're pulling the data from the array. But if you will say, I want to take this data source, array, WebSockets, whatever, and you will start over time sending data, now we are talking about observable stream. You can create observable from the event. You keep clicking on the button, on the key up, you want to send an element. So you can link the key up to using this from event, and you'll get this stream right away. You can turn a promise into observable. You can generate a range of data. There is so many different ways to do this. Now, as I said, when the data flows through your algorithms, you can compose and chain the operators. What is an operator? It's a function. It's a transformer, basically. It takes an observable that comes in, it does its things, say multiply by 2 every element, and it outputs another observable. Always, any operator takes an observable in, sends an observable out. That's why we can chain them, right? It's always observable in, observable out. Let's use beer as an example. And this is the second reason why people don't get how Rx works, is because many examples in the documentation are not about real life. That's why we'll use examples about beer, so everybody understands and like beer. Let's say we have an array, beers, right? A whole bunch of elements. Now we want to turn an array into observable stream, right? Easy. Rx.observable from beers. Now, of course, I didn't put any delays in there, so technically it'll take all elements and it'll shoot at whom? At the subscriber, if any. After this last line on the screen, nothing happens. No data is moving at all. We're just declaring. So we will create an observable stream named Observable Beers, and if somebody cares, let them subscribe to it. If nobody cares, no data is moving. Now let's look at the first operator, filter. So we have now our variable observable beers dot filter. We're saying I want to filter out the beers. How? I pass this function as an argument, right? In green. I want to have it's a lambda, it's a fat arrow function, right? We are saying whenever beers come in, check if it's price less than $8, keep it. Otherwise, skip it. Right? So whatever we have in green is called pure function, right? And the filter in this case is a higher order function. Now what I can do, I could put another operator right below filter, map, or anything else. There's many of those. So I can keep chaining the processing. But until I do subscribe, no data is moving. Let's look at this line up on top. I'm saying create an observable from my array beers, declare that we want to filter it out and see only those that are cheaper than $8, and we want to map them. What is map? Map is always about transformation, transforming something from this type to that type. I had an array of objects. Each object was a beer with 3 properties. Now I don't care. I want to turn it into a string, right? I take beer name, attach a symbol $, and beer price. So that's cool. we have operators, and now we want to subscribe. How do you subscribe? When you subscribe to an observable stream, what do you need to provide? An observer, something that that knows what to do with the data. So what observer has to know? Has to know how to do A, what to do with the data, B, what to do with an error, C, what to do if the stream is over. If you don't care, don't put the code for handling end of stream. If you don't care about errors, which would be strange, but still you can skip this error thing. So in this case, I say subscribe. Now I say I'm interested in the data will start moving, and what I pass to the function subscribe, 3 functions, right? For next, for error, and for complete. So the top portion is just a declaration. Typical errors. I see this error on Stack Overflow. Many people do this. Why don't I see the data? Because you didn't subscribe. It looks like I'm calling some function like filter map. They don't work until I subscribe. On these slides, you will see the links, at least in the Rx portion of the presentation. I created a bunch of these small examples on Plunker, so you can run them right away. So like in this case, for example, I click on the link, it goes to Plunker, and that's the code. See, in the index.html, I am just adding a Rx library, one-liner, nothing else, right? And the script itself, I have that beer, right? What else do I have? I show you 2 different ways of printing the beers. In the first portion, I do just for each, array for each. This is no Rx, it's just a standard API. It's polling the data over here. I just want you to see that it's very similar in a way. Over here, starting from line 19 down, I am doing Rx processing. I turn the beers array into observable, I do filter, I do map, and I subscribe. So now if I will, let me do this, I will stop, and I will open up the console. Let me clean it up. And I will just press the button run. All these little examples from Rx portion, you can just run from your computer, from your browser. I click run, and it will execute my code. See, in the top portion, I am just using for each, not Rx. In the bottom, I do Rx. So basically, the result is the same in this example. If I will click on another link, I don't remember what was there. We'll see now. I think create. The method create, again, the same beer. Yes. Check this out. I want to create a beer, and I want to be in control when I will be pushing the data. In this case, I say create for me an observable. What do I give? What do I need to give to an observable? An observer. Over here, that's the place where you would put the business logic from your application. For example, you are connected to WebSocket to your server. The data comes in, right? So over here, you do your processing, and you make a decision that yes, I need to send the data to the client, to the observer. How do you send it? Right there. Just call the next on the observer object. Who is the observer object? Where do we see it here? We don't see it here. But what we are saying, if somebody ever will subscribe to this observable, they will give us an argument, right? And that's the argument which is observer. And in the code, we are saying what to do with this observable. In this case, I'm just sending over the entire, not the entire. What do? I'm saying for each element in beers, I'm just calling next. This is push. All right? Now, so that was the function declared, get data, right? And this is where I'm calling the function get data. So if I will just run this code, again, let me open up the dev console, you will see a similar result. So in this case, I am manually calling next. So whenever you want to connect to the data source, you have just invoke next manually. Marble diagrams in Rx documentation to make the explanation easier. They came up with these diagrams. They call them marble diagrams. So when you will be learning about operators in Rx, you will see something like this. How to read it? Up on top you see a stream. In this case, it's a stream of circles. Right at the end you see a vertical bars, meaning the stream is over. Then in the middle you see an operator that they want to describe. In this case it's map. So what do we read? We read that the map operator will take a circle as an input and will produce a diamond as an output, right? Some kind of processing. So what is down there? What is an output stream? Stream of diamonds, correct? So now we can guess what's going on. If you look at the filter marble diagram, similar things. You have a stream of different shapes, right? We don't care about all the shapes. We want to filter out only the circles. So the output stream will be circles. You can change them up. You can change map and filter, right? I didn't want to clog the slides, but you can bring together all these diagrams. So coming back to brewery, change the way you think about the programming. Instead of doing imperative programming, like I will do this and then I will do that. Maybe the data is not ready for you, especially in the asynchronous mode. How you can say, I'll do this, call me that. You can call 10 times, but if the response didn't come back yet, so what's the point? Or you keep polling. So you need to think about it this way. The data is flowing through a bunch of algorithms, a bunch of operators. Like the beer is flowing through different stages, right, until it's ready. So what you do is you define a function for each specific operations, right? And you change them together. Composable function, composition is great. So if you will change the way you think about the coding, it will be great. At least start again. You don't have to change completely your understanding of programming. In some place, think if you have data that has to do through several stages like beer, write small function and change them up. Error handling. As I said, if observer gets an error, if observable will invoke an error method on the observer, the stream is over, we get an error. In some cases, we don't want to stop the processing. And there is so-called reactive manifesto, and they describe a bunch of characteristics that will make a system reactive. One of them is resilience. The system is resilient. The server doesn't fall down if you will overload it. How to do something like this? It means that first of all, you have a dedicated channel for errors, and B, you can handle the error and make sure that the system is alive. How to do something like this? Using operators. There are operators besides the error. Error, of course, is like it's the situation when we say we report to the observers there is an error. But if what you can do before the subscribe, you can say catch an error, and it'll intercept an error, and there you can put the business logic, and you can say, oh, if the error is 500, then switch over to a different data center and subscribe to a different stream, right? So basically, you can keep the system alive. Or if you are getting an error, using the retry operator, retry n or retry when, before the subscriber, then you can say, all right, so I'm getting an error now. Maybe the server is not up yet. Let me try again in a second. And there are ways to program it. So try again in a second. It's still not there. All right, let's try in 5 seconds. Let's try in 10 seconds. So there is a way to do something like this nicely. All right, so Failover will sketch will look something like this. See, I have catch before the other operators, before the map and before the subscribe. So if the error comes in, it'll jump right into catch. I will check if it's 500, do this, otherwise do that. So I can resubscribe to different streams. There is a plunker, so you can try it out. I don't have time for this, but trust me, it works. Another operator, flatMap. flatMap. You may have a stream where every element is not a simple thing. It's another observable with other nested elements. Think about the beer, which comes in pallets, right, to the store. And then pallet comes in, it's an observable, which has something else. And then workers start taking the cases out, right? This is another stream of cases in this case. So we need to take a pallet as an element and unwrap it and unwrap the cases. So this is something that is called flatMap. Of course, you could have written it in another way, like I have a subscriber, subscribe to pallets. This is palette of beers, this is palette of soft drinks, and so on, right? And then inside the subscribe, I could write another subscribe, so to unwrap the palette. Instead of that, you can just write one flat map. In this case, let's look at this. I have an observable beers, I have an observable soft drinks, right? And I do create. This next pushes the whole observable of beers. This next pushes the whole observable of soft drinks. Somebody has to unwrap them, right? So what you do is you say get drinks, right? And say flat map. You are saying that I know that you will get nested observables. Just subscribe to me. So if you will run this plunker, you will see whatever. You will see Stella, Sam Adams, Bud Light, Coca-Cola, Fanta, Lemonade. It'll be flat screen, flat stream. Operator concat. I just give you some of them, but there's a lot. Concat. What if you have more than one stream? Say you connect to HTTP requests there and HTTP request here. By the way, in Angular 2, HTTP by default returns observables, so you have to subscribe. Not the promise, but observable. So say the first request takes 4 seconds. But you, for some business reason, you cannot make another HTTP request until the first one is done. Concat. You declare an observable using the timer. In this case, I am emulating 4 seconds. Like as if it returns me first response. Map2 will just return me a value, hard-coded. Over here, I could have used HTTP. This guy works once. This guy supposed to start in 1 second. The first one in 4, the second one is in 1. But what I do is I say I want to concatenate these two guys. The 4 second comes first, meaning until the subscription from the first one is still up and running, the stream is coming in, you will not subscribe the second one. So concatenation gives you this way. There is a zip, there's so many. Look at this. These are operators. So if you will spend enough time to figure out how the whole thing works, there is operator for anything. Give me samples every 5 seconds. Skip. Give me the first one. Give me the last one. You name it. Generate data every 1 second, every 10 seconds, every hour, and so on. Share the stream between multiple subscribers. All this works fine. So now let's talk about Angular. As I said, this library RxJS is embedded, not embedded, but it's included. It comes with Angular. You have it installed right there. And now I'll show you a couple of other examples from Angular 2 code. But again, I'll show you specifically examples that use observables. So the code samples you can find there on the GitHub, but I will show you several areas in Angular where we use them. Forms in Angular. You have a form, and you define every form element in the form, right? And Angular gives you right there a special property on every, actually there is a class called form control that represents every form element. So what they give is they say there is a value changes, it's already observable. Subscribe to it if you care. So the user types in the field, boom, 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 stream, pushes. If you want to see if the status of the form has changed, subscribe to that property. It's already observable. They give it to you. In this example, what you see is I have a simple form with one input element, and this is how I use binding in Angular to say that this is a form control should be handled by Angular. I create an instance of onControl. As soon as I did it, I have value changes property on that field. On that field, I can subscribe to it. I do subscribe, but before subscribe, what do? I use debounce time. Something is wrong. I do debounce time operator. In this particular case, debounce, not in this case. Debounce time means if the, why do I do this? Imagine that user keeps typing in the field, and in case of Google, it would immediately do a multiple request to the server to find something. You don't want to make a request while the user is typing, right? So debounce time means if the user stops typing for 500 milliseconds, now let's do a request, right? In this case, I'm just generating the price of the stock using hard-coded random function, but technically this could be making a request, a HTTP request to some server with stock quotes. HTTP and observable in Angular, how this works. Angular has a special object called HTTP. It gets injected into your class, into your constructor, HTTP, right? So what do? I say get, and this is a REST endpoint. In this case, it's products. And I also apply map. When the data comes, I'm saying extract me JSON from there, right? And then subscribe. If the next element comes in, the first piece is what to do with the data, right? The data comes in, we assign it to property products, and products is bound somewhere on the UI in HTML. It's not shown there. Async pipe. In Angular, there are some so-called pipes. If you expect data over here, you can put a vertical bar and do a conversion. For example, you want to display a number as a currency, or you want to display a date in different formats. In this case, they also give you async pipe. Async pipe is automatically subscribes to the observable. Products in this case is observable, unwraps it, and renders on the UI. SwitchMap operator. Excellent operator. And probably I'll do this demo, and this demo will be the last for today. The worst documentation, if somebody will ask me if you can name the worst documentation ever, it's about switchMap operator. I didn't want to show you over here, but if you will read it, I mean, it's like as if that person has a goal to write something that nobody will ever understand. But you're lucky because you came to this conference and I'm here and I will explain it. Even if you wouldn't read that documentation, even this picture can give you an idea. So what does it do? What it does is there are two streams, two observable streams. The first one and the second one. The first stream sends you an element. The second picks it up. There is a function that returns another stream and it handles it. But switchMap works this way. If the source, the first stream, gives you the next element, the inner stream, so to speak, get killed, and it starts handling the new element. To put it simple, think about it this way: you have an application. The user enters something in the input field. Boom, the HTTP went out there to get the data back, right? Now, what do? And the connection is slow, right? The user is angry, I don't get my data. The user enters something else. I wanted to get the price for IBM, and now I will do the price for, we are at Microsoft, for Microsoft, right? So what happens on the slow connection? Two requests are out there, right? They will come back sometime. So the switchMap operator allows you to say, oh, he entered Apple. The inner stream is working now, but went out. It's still pending, it didn't come back. But he enters something else, the first one will get killed right away. So I will show you this example, and then I will switch to questions. I have a lot more stuff, but it's only 45 minutes. So what I will do, I will show you this example. This example, one second. It's a project, little project. It's a little project I'm using WebStorm and Observable Events HTTP, right? So what I will do, I will say that I want to run observable event HTTP. This is a little sample that connects to a server. I don't even know where it is. It returns the weather. So you enter the name of the city, it goes out there, returns you the weather. What I will do, I will run this application, and first of all, you'll see that the weather comes in, and then I'll show you what is under the hood. So what I will do now, npm start. Right, so this is observable weather. Let me open up the console. So I will enter New York. Look at this. As I was typing, this connection is pretty fast. Look at this, how many network requests it sent out. Actually, let me look at the network tab. I type in N, boom, it went out. Then new, then again, new and space, new, your, New York. Look at this, how many requests went out there. Now imagine a situation that we are on a slow network with a mobile phone and so on. Do I want all these requests running around? No. So what I will show you, I will turn on the throttling to emulate a situation that if we are on a slow network, right? I am emulating 50 kilobit per second, right? Now, I will do the same thing. I will start typing something. And you watch what's going to happen in the network tab. I will be entering London. Again, I'll be typing slow. Look at this. See, the first with the letter L went out, and then I entered LO, boom, new request, the inner observable get killed. Then I enter LON, the same thing. So all these are dead. With one operator, system, switchMap, sorry. Excellent way to go. Now the router, Angular has a router, right? So in the router, what you have is, you have an area called router outlet. It's a single page application, right? In this little area, you show different components based on the routes. As you switch components in the router outlet, you may need to pass parameters. You may have a situation that component is sitting in the router outlet, but the user keeps changing data in the other area of the screen. In the router, you can subscribe to data using this subscribe. It's already there. Angular 2 has dependency injection. I'm rushing through because I have like a couple of minutes left. So what happens is, look at this UI. When you build your UI, it contains different components. Components may be sitting inside the containers. And what do we do? How a component A can send data to a component B? Are they even shown at the same time at this moment? Maybe the router doesn't show them at the same time. What happens is you can create a common injectable service, which will be injected into all these components that are supposed to communicate with each other. And then using subscription, component A sends or changes a property on the service sends the event, and component B subscribes to this event using, again, the same observable idea. EventEmitter. You can send any custom event that you want. So there is a class EventEmitter in Angular. You create a new instance of EventEmitter, and in this case, you're saying emit. So a new custom event will go out. How do you get it? You subscribe to this object, right? And then you print it. So using this, you can arrange states, state service, and so on. So I get signals that I should stop. So I will. Let's do a QA, 5 minutes. Yes, some information about me. I'm blogging a lot. I wrote like 1,000 blogs. Last year, I was blogging a lot about Angular 2, so if you want, just go to my blog and read. Yes, questions?
So for an observable stream, are there any good transforms for handling asynchronous data? Like a lot of the transforms that you're showing seem to be just synchronous, like map or filter.
No. I was showing you examples because I want to make them quick. observable and Rx is meant mainly for async operations, especially for situations when you don't know which one comes first. You can join the observable streams in any different ways. So the answer is no. The fact that you remember that I was converting an array of beers, but I was also showing HTTP request, right? Which is async. It is for async. Some people will say that RxJS is like Lodash for asynchronous processing.
Okay, thank you.
Once the close event has been emitted, can it be reopened? Can the stream be started?
If the stream was closed, you have to resubscribe.
You have to resubscribe.
The stream is over in two cases. Either somebody invoked complete or an error happened. In both cases, the resubscription is required. By the way, the observable you can have one observable and share with different UIs. For example, you may have a stream of data, stock prices, and you want to show them over here as a chart and over here as a table, right? You have one stream, and there's a special operator share, and both subscribers from the same screen can use it. Any other questions? Yep.
The Plancker examples that you showed, where can we find them?
So I don't know. Where can they find them? They are on the slides. Do you publish slides anywhere?
Yeah, well, the videos will be published.
On the video next week.
On the video.
On the video, you will see all these slides. Anyone else? All right, to sum up, I highly recommend you to use Angular 2 framework. When you will move to Bay Area, then it's up to you. But while we are in New York City, Angular is your way. Thank you.